Don't know how to install NVIDIA drivers? Stay tuned to see it. If you haven't installed Rocky yet, watch this video and come back. When the system boots, it enters the desktop environment. We watch the tour, then open the terminal and make it much larger. First, we install the EPEL package. It expands Rocky Linux with additional packages maintained by the Fedora project for users. Then we install the Fastfetch package to view system info. It depends on the high-performance YYJSON package to run well. Now we run Fastfetch to check the system information, mainly if it recognizes the NVIDIA graphics card. It is listed as GPU1. We run NVIDIA SME and see that the drivers are not installed. Apart from EPEL, we enable the CRB code ready builder repository. We use DNF to install RPM Fusion free and non-free to expand Rocky Linux repositories with software not officially available. This allows access to multimedia codecs, extra tools, firmware, and proprietary drivers, such as NVIDIA ones, for installation. We run the DNF search NVIDIA command to list packages related to the graphics card, hoping that version 580 is available now. This version is compatible with my card. We install akmod NVIDIA 580XX, the X11 driver, and also the CUDA toolkit package. After pressing yes, the installation of packages and dependencies will start, including common ones like kernel devel. NVIDIA module building will start like Fedora. It shows no progress. We run top to see that the akmods process is running. With modinfo, we see the module is not installed yet. We can also use ps-awk-rep akmod and see there are still many processes. We continue giving it a little time for building, verifying with ps-odds to see if the akmod processes are finishing up now. But after several minutes the processes continue running. We keep waiting and testing commands until they drop from the list. When reduced, we can run modinfo again. This time we have an answer from the command. The module and parameters are shown. We run sudo reboot to restart the system so the module loads correctly. The system boots and shows the default user account. We enter the password to get into the desktop environment, then we open the terminal, increasing font and window size. We run NVIDIA SME. Now it works. We install GL Mark II and Hashcat, but even with EPEL installed, the packages are not available. Now we install development tools to get compilers, debuggers, and utilities needed to develop and compile software projects. To complement the compilation packages, we ensure we have Meson, Ninja Build, Chemnik, GCC++, Git, and other needed libraries. We clone the GL Mark II repository directly from GitHub. Wait for it to download the necessary objects, then change directory. To install GL Mark II, we use Meson setup build and leave the local prefix and the X11, X11 GLES, Wayland and Wayland GLES options. When running it, it shows a GLES dependency error, but shows that GLES 2 is available. We run it again, but protocols are missing. Now, we must install the Wayland protocols devel package for compatibility with the desktop environment and the test package. We try to run Meson again, but now an error appears because the libjep dependency cannot be found. Everything else is fine. Now we must install the libjpeg turbo devel package, which is necessary to compile programs that process JPEG image files. Finally, we run the Meson command, and this time it performs the necessary build and GL Mark II dependency configuration. Now, we run the Ninja C build command in the build folder to compile the project using rules previously created by Meson. Ready now. We compile and install the software from the build folder into system paths, copying binaries, libraries, and files. We run GL Mark II and it uses the default card to render, which is the Intel card. Build measures driver and graphics capability. Effect 2D evaluates accelerated 2D rendering. Desktop simulates a real desktop environment to measure compositor performance. Refract, this test simulates light refraction through transparent surfaces. The score obtained by Intel is considered average. We run GL Mark II with environment variables, offload and vendor to render with NVIDIA. Bump simulates relief via bump mapping. With the jellyfish test, it renders many semi-transparent objects in motion. With shadow, we evaluate dynamic shadow projection. We continue with loop, a test that evaluates the efficiency of loops within shaders. The score obtained by NVIDIA was excellent. We installed the EPEL package. This package is necessary so that when we download, compile, and run Hashcat, the GPU works. Then, we clone the Hashcat repository directly from GitHub, wait for it to download the necessary objects, then change directory. After cloning Hashcat, it is enough to run the make command, because the project includes its build rules and dependencies. It takes time because it compiles many modules, graphics kernels, and components to support multiple algorithms and execution modes. Now we run make install to install Hashcat in the system, copying binaries, modules, documentation, and files to the paths. We run Hashcat B. CUDA is tested using hash algorithms. MD4 and MD5 are old methods, while SHA-1 is a more secure choice here. SHA-256 provides greater cryptographic resistance. SHA-512 uses longer hashes and needs more resources. On average, it was excellent. We have finished the evaluation of Rocky Linux. We close everything and turn off the system. We will present conclusions. In conclusion, the installation process of the NVIDIA drivers was long, but if executed correctly, everything works fine. What took time was compiling and installing the graphics performance test packages, as they were not available in the repo. However, graphics performance was quite acceptable since the Intel card had average performance, but NVIDIA was excellent. This has been all for this video. If you liked it, subscribe, leave a like, and activate notifications. See you in the next video.